My dear students of Btech second year, I wish to teach you through lecture 2 solution of polynomial and transcendental equation by regular falsy method with examples. First of all, we understand what do we mean by regular falsy method or method of false positions. In this method also we find the two values of x, say x1 and x2, where f of x has opposite signs and there is only one root in the interval x1 and x2. Let us express the function of y equal to fx and are intersected in finding the value of x, where curve y equal to fx intersect x axis, that is y equal to 0. So we identify 2 points x1 and y1, x2 and y2 on the curve. Then we approximate the curve by a straight line joining these 2 points. Now we find the point on the x-axis where the line cuts the x-axis. So for that you have to put y equal to 0. Of course, the equation of the straight line passing through x1, y1 and x2, y2 is given by, we know that by coordinate geometry. How can we find the equation of a straight line passing through 2 points? One is x1 y1, another is x2 y2 is y minus y1 equal to y2 minus y1 upon x2 minus x1 into x minus x1. Therefore the point on x-axis where y equal to 0 of course is given by it. In this equation you will put y equal to 0, you will get the point on x-axis, that is, after simplification this gives to you x equal to x1 y2 minus x2 y1 upon y2 minus y1. Now we check the sign of f of x and proceed like in the bisection method as we discussed in the previous method. Similarly we can proceed now. So that is, if f of x has the same sign as f of x2, then root lies in the interval x1 comma x, and if they have opposite sign then it lies in the interval x comma x2. See the figure subscript shows the iteration numbers. So this thing we have been explained by graphically. Suppose this is the graph of function y equal to fx and this is the point for first iteration. For finding the range of interval, your interval is x1 and x2, and then you can, for first iteration you will put this. Let me understand this method by an examples. So our first example is find the positive root of this equation x cube plus 4x square minus 10x equal to 0 by regular falsy method. Compute up to the 2 decimal places only. As long as you not get 2 answer correct to 2 place of decimal same, you will continue this. So it is the same problem as given in the previous example. So we start by taking x1 equal to 1 and x2 equal to 2 as the range of the solution. We have y equal to x cube plus 4x square minus 10. So you will find at x equal to 1 the value of y as say y1, and at x equal to x2 you will find the value as y2 is 14. Therefore the point on the curve are, you are getting the point on the curve are 1 comma minus 5 and 2 comma 14. That's why you can find the points on x-axis where the line joining these 2 points cut it, given by as first iteration you are saying as first iteration. So 1 into 14 minus 2 into minus 5 upon 14 plus 5. So this value this gives to you 24 upon 19, that is equal to 1.26. Now again you will find the value of f of x, that is at 1.26, the value is minus 1.65. Therefore you repeat this second time this above methods. Take the points 1.26 minus 1.65 is the corresponding value of y, and you have already the value is 2, 14. And then again you find the value of x by using again the regular falsy method, the formula. So this answer is 1.34. Since again you will find the value of function at that point is minus 0.41, that's why you continue the third iteration. Now take the 2 points 1.34 corresponding to this is minus 0.41 and 2, 14 is already there. Now again you find x at 1.34 into 14 minus 2 into minus 0.41 upon 14 plus 0.41 divided by this gives to you 1.36 numerically. Again since you will find the value of y at this minus 0.086. As we come to the fourth iterations, take the 2.1.36 minus 0.086 2.4. Again you can find x is 1.36. Since the value of x repeated, we take the root as whatever may be the value you are getting here 1.36, because you are obtaining in the previous steps as 1.36 here you also get, and for when you repeat next time here at 4 iteration there is 4 times when you repeat this method you will get 1.36 again. So that's why the x value repeat हो गई है. Now we stop. That's why we can say that the answer of the given question is 1.36. So let me take another example of transcendental equation. Transcendental equation means a equation which is not to be completely algebraic is called transcendental function or transcendental equation. That is an equation which involves sine function, that is trigonometrical function, logarithmic function, exponential function and geometric function. We call as transcendental equation by the false position correct to 4 decimal places. As long as you are not getting 4 decimal places same answer, you repeat this process. So again we start here. This is your given question. Again you find the value of function at these 2 points, say x equal to 2 and x equal to 3. You are getting opposite signs, therefore a root lies between a equal to 2 and b equal to 3. Or you can say x1 and x2, you can say that there is no problems. So by the method of false position you are applying this formula as by saying that x1 equal to a of f of b minus b of f of a upon f b minus f of a. This is the general formula. Therefore we get x1 equal to, on putting these values to here you will get the value is 2.7210. Then you find the value of the function at this point is minus of this, minus of 0.01709. So you are having this is minus and this is plus. It means now the root lies between x1 and 3, that is a equal to, you will take 2.7210 and b you will take as 3. When you repeat this method second time, now the root lies between, as I am saying to you, a means this x1. So because the functions are of opposite sign, similarly by the false position method you are applying this formula here, x2 you are getting 2.7402. So still you are not having only first place of decimal, you are having same answer. You have to find the answer correct to 2 places of decimals. At least and maximally 4 places of decimals. So again you have to repeat the same method by finding the value of the function at this point. This is to be positive and previously you are having negative, so you will again proceed towards positive negative sign towards direction. That is, now the value lies between 2.740 and b equal to 3. Again find by pulse position x3 equal to 2.7406. You are having 3 places of decimals. Your answer are correct. Hence the desired root is 2.7406. We can conclude that as our demand is of desired accuracy. Thanks.